Hello students, I hope you all are doing good and preparing well for DCET exam. Uh, so in today's video, so this will be the continuation of the previous video. So if you have not watched the previous video, you can go check that out first and then come to this video. Uh, okay, so as you all know, in this video series, I will be covering straight lines topic that is in your DCET syllabus, 2023 syllabus. I'll be covering all the topics. There are totally 4 topics. So this is the one topic that I have started. And subsequently, I'll cover the other topics as well. Okay. So let's start today's session. Okay. Okay. So what have we got? Mm, okay. So in today's session, we will be covering these topics. So first, so this today's is an interesting topic. So we will be understanding what is slope, what is the condition for parallel and perpendicular lines, given two lines, how to find the angle between them, and the equation of horizontal and vertical lines. So we will be covering these topics in today's session. So let's start today's thing. Okay. So the first concept we have is slope of a line. Okay. So when you hear this term slope, what comes to your mind? Okay. Slope is nothing but, how should I explain this? Okay. Imagine you are walking uphill, meaning you are climbing. Say this is something, some mountain, and you are climbing. Okay. If this person wants to climb uphill, meaning upwards, okay, it will be difficult, right? And if you see this, to climb this one, to this mountain, it will be easier, and this will be less more easier, and this will be the easiest to climb because it is less steep. This one is less steep, so this one will be easier to climb. Okay. So for a person, this one will be hard to climb, and this one will be easy to climb, right? So uh, so just try and understand this. This path is difficult and this one is easy. Okay. So in mathematically, how can we define? Okay. So here we want to define the slope of a line. Okay. So if you look more closer, if I take this as my reference line, and if I take this angle and I call it theta, I'll mark it for all the lines. Let me call it different: theta 1, theta 2, theta 3, and theta 4. So you can see, right? Theta 1 is greater, right? Theta 2 is smaller than theta 1. Theta 2 is greater than theta 3. Theta 3 is greater than theta 4. So theta 4 is the least one, right? Theta 4 is the least one. So using this angle, I can tell whether it is steep or not steep. If the angle is more, in case of theta 1, it is difficult because to climb this, it is going to be difficult. If theta is small, I can easily climb. Okay. So using this theta, we can define a slope of a line. Okay. So in mathematics, there is a term, okay, to define exactly the slope. What we do is we take tan of this angle. So tan of that angle will give us the slope, and it is denoted by m. So whenever you come across slope of a line, it is nothing but the angle that it makes, okay, and tan of that angle. This is nothing but the slope of the line. Okay, that's it. Okay, you will come to, you will understand this. Just stay with me and follow. Again, imagine, now imagine you are coming down from a hill. Okay. Okay, so this one will be, you will just slide, right? You will just fall because this is steeper. Here you will have to walk. In this case, you will have to walk. You will not just fall. Okay, so here, if I call this as theta 1, theta 2, theta 3, and theta 4. Here, as theta increases, theta is increasing, it is becoming less steeper. Okay, and it will become more difficult for me to, I'll not slide, I'll have to walk. In this case, right, here I'll slide. Okay, so here important thing that I want to highlight here is, when you're coming downhill, what will happen is, see, this angle theta is greater here. Okay, here you are coming down. In previous case, we were climbing. Okay, so our theta was less than 90 degrees. In that case, theta was less than 90 degrees. Okay, but here, in case of downhill, the theta is greater than 90 degrees. Okay, see here, it is greater than 90 degrees. All theta 2, theta 3, theta 4 are greater than 90 degrees. So understand here, when we are taking tan of an angle which is more than 90 degrees, okay, in this case tan is more than 90 degrees. In that case, this will be negative. This will be negative. Okay, tan of, when downhill, it will be negative. More the negative value, see, in this case tan of theta 1 will be greater. Absolute value I'm talking. Okay, tan of theta 1, absolute value, meaning ignoring the minus sign, tan of theta 1 will be greater than tan of theta 2, greater than tan of theta 3. Okay, so see, I'll tell you with an example. So here it will be minus 3, say, here it will be minus 2, here it will be minus 1, here it will be minus 0.5. So more the value, it is more steeper. Okay, more you can easily fall, and less the value, as the value decreases, negative value, you'll have to walk. So that is the meaning here. Okay, whenever tan, so here also, to define slope of these lines, we'll just take tan of that thing. Okay, tan theta will give us the slope. Directly it will give us the slope, and it is denoted by m. So this is, I have just explained you. If it is positive, imagine you are climbing, and if it is negative, imagine that you are coming down, downhill. Okay, coming down. So this is the concept. Moving forward, okay, one more thing I want to explain you all. Say, if a line is like this, just horizontal, so it has got no slope. That means, what is the angle? Angle is 0. What is tan 0? 0. So the slope of this is 0. Say a line is exactly perpendicular. So how can I define the slope of this line? It will be tan 90, right? Tan 90 is not defined, right? Remember this thing. Okay, so this is our slope. So we talked about slope. Okay, one more thing I want to uh, cover here is, so tan theta is nothing but, the theta is the angle made with the positive direction of x-axis. This is the positive direction of x-axis in anti-clockwise direction. This theta, the tan of theta, this theta is always taken in anti-clockwise direction with positive direction of x-axis. Anti-clockwise meaning in this direction. Okay, this is anti-clockwise, right? Okay, so this theta, this is theta. Okay, so see, here I have got a line. This is my line. Okay, I have plotted it on a 2D, on a graph paper. And if I ask you what is the slope of this line, so what do I mean by slope of this line? Nothing but tan of this thing, right? So it makes some angle theta with the x-axis. I want a tan of theta. Slope is nothing but tan of theta. That's it. Okay, so how can I find the tan of theta? So okay, you understood that, right? So if I draw a triangle here, this is 90-degree. Okay, this is theta, this is a triangle. Okay, so how much is this? This is one unit, right? And this is 2 units. What is tan theta? Opposite by adjacent. In your trigonometry you have learnt this. I hope you remember this thing. So tan theta is opposite by adjacent, that is 2 by 1. So this is the slope of this line. The slope of this line is m is equal to 2. So this is how you find. There is one more method. If you have 2 points, I'll show you. This is one way. Say I have 2 points. What will be this point? In our previous session, we understood how to locate the points. Okay. So tell me, what is this point? It is 3 comma 3, right? And what is this? This is 2 comma 1. Okay, I have got 2 points that are on this line. Using this data also, I can find the slope. Okay, how we can find? I'll just tell you. So I want this distance, right? This can be found out using this, right? This is 3 units, and this is 2 units. So what will be this? 3 minus 2 is equal to 1. Similarly, this is nothing but this minus this, right? 3, so sorry, this is 3 minus 1, so it is 2. Okay, so nothing but 2 by 1. There are two methods of doing that. Okay, I just showed you. So slope is nothing but tan theta. If the line makes some angle with the x-axis and you are trying to find the tan of that thing. Okay, moving on. Okay, so this is the direct formula that you can use. I'll just show you how this formula comes quickly. Say you have got 2 points. This is x1 comma y1 and this is x2 comma y2. Okay, so I'll just draw a triangle here. This is my theta. So this will be nothing but x2 minus x1 and this will be y2 minus y1. So what is tan of theta? That will give me the slope y2 minus y1 by x2 minus x1, and it is denoted by small letter m. Okay, so this is how you do. So you can just remember this formula. Okay, given 2 points, this is how you find the slope of the line. Okay, simple. Okay, so here is a simple problem. So we have got 2 points, x1 comma y1 and x2 comma y2. Okay, so what is the formula? It is y2 minus y1 by x2 minus x1. I'll just substitute here 8 minus 7 divided by minus 2 minus 3, right? 8 minus 7 is 1 minus 5. So this is the slope of the line. Okay, simple thing. Okay, just we applied the formula, we did nothing. Okay, very easy. Okay. Okay, moving on. So this is slightly trickier question. Find the slope of a line making 60 degrees with positive direction of x-axis. Okay, so here they have given us the angle. Okay, they are telling it is some line, we don't know. It makes 60 degrees. Okay, and they are asking me to find the slope of this line. Slope of this line is nothing but tan of this thing, right? Tan of theta. We already know the theta. It is tan 60. What is tan 60? Yes, you are right. It is root 3. Okay. So the correct answer is root 3. That's it. Very easy. So understand here, they are telling positive direction of x-axis. It is positive and we need to go in anti-clockwise direction. Okay. This direction. Okay. Okay. Moving on to the next concept, slope of parallel lines. Say we have got two lines. Let me call this L1 and L2. If these two lines are parallel, then what will happen to their slope? Okay, these two lines, if they are parallel, I'll just extend them. The angle will be same, right? The angle that they make with the x-axis will be same. That means their slopes will be same. That means m1 will be equal to m2. So this is the condition that you need to remember. Whenever two lines are parallel, their slopes will be equal because they make the same angle with the x-axis. Okay, moving on, perpendicular lines. So what is the condition for two lines to be perpendicular? It is very important. You can expect a question from here. Let me just extend this. Okay, so what we know. Okay, so let me call this theta 1 and theta 2. With this information, what can I tell? I know it is m1 and this is theta 1. That means m1 is equal to tan of theta 1. Everyone agrees? Slope of the first line, slope of the second line is tan of theta 2, right? Okay, observe, listen here, look here, uh, observe here properly this triangle. So here this is 90 degrees, this is theta 1. So in this triangle, if I apply the exterior angle property, you can just Google that out, what is exterior angle property. So you can see here theta 1 plus 90 degrees, theta 1 plus 90 degrees is equal to theta 2. Okay, this is a simple thing that I have obtained from this diagram. If I apply tan on both sides, tan of 90 plus theta 1 is equal to tan of theta 2. Tell me what is tan of 90 plus theta 1? Tan 90, it is a multiple of 90, so I have to write cot theta 1, and this will be in second quadrant. In second quadrant, 90 plus theta 1 is in second quadrant. In second quadrant, tan theta is negative. So it will be cot theta 1. So I have this relation. I can write minus cot theta 1 as 1 by tan theta 1, agree, equal to tan theta 2. This is nothing but tan of theta 1 tan of theta 2 is equal to minus 1. So the condition for two lines to be perpendicular is the product of their slopes. We denote slope using m, right? m1 m2 is equal to minus 1. Okay, just remember this. You can make a note of this thing also. It is very important. Okay, moving on. Okay, coming to a problem. So coming to a problem, line through the points minus 2 comma 6 4 comma 8 is perpendicular to the line through the points 8 comma 12 and x comma 24. Find the value of x. Okay, very easy. They have given us two lines that are perpendicular. So what we have to do, we have to first find out their slopes m1 and m2, and we know the property m1 m2 is equal to minus 1. I'll just apply that. Okay, first let me find what is m1 using these 2 points, y2 minus y1 by x2 minus x1. 8 minus 6 by 4 plus 2. 8 minus 6 is 2. 4 plus 2 is 6. Let me just check. Yeah, I'm right. It is 1 by 3. What is m2? 24 minus 12 divided by x minus 8, which is nothing but 12 divided by x minus 8. So m1 into m2 is minus 1. I'll use this condition now. 1 by 3 12 x minus 8 is equal to minus 1. Simple, right? 3 ones are 3 fours are 4 is equal to minus x plus 8. X is equal to 8 minus 4 is equal to 4. So this is how you find the uh, value of x. So x is equal to 4. So we use this condition m1 m2 is equal to minus 1. Okay, moving on. Okay, yeah, this is a important thing. Okay, I'm sorry. So angle between two lines. Okay, so we have got two lines L1 and L2. They make angle, let me call this theta 1 and theta 2. So they let us define the slope for this as m1 and slope for this as m2. So the angle between them, this is the angle. So to find, we know the slope of these two lines m1 and m2. If I have got two non-parallel lines, they will meet at some point, right? They'll meet at some point and they'll make an angle. So that will be the angle between the two lines. So how to find? Okay, there is a direct formula for this. You can refer the textbook for the derivation, but I will not go into the derivation part. You can refer that. So the direct formula for that is, so this is the theta. Tan theta is equal to modulus m2 minus m1 by 1 plus m1 m2. So you can remember this formula. It is very important. You can expect questions from here. Okay. So whatever value we get, if we get minus 3, modulus of minus 3 is nothing but 3. So if it is negative, make it positive. If it is positive, keep it positive. So that is the meaning of this modulus. Okay, very important. Okay, so whatever you get. So this theta, one more important thing is this theta is the acute angle between the two lines. Acute angle between the two lines. Okay. Whatever the tan theta we get, the theta is corresponding to the acute angle. Moving on, we'll solve a simple problem. If the angle between two lines is pi by 4 and slope of one of the lines is 1 by 2, find the slope of the other line. So they have given us m1 is 1 by 2, and tan the angle between them is theta, that is pi by 4. We need to find out m2. Okay, let's apply the formula. Tan theta is equal to modulus m1 minus m2 by 1 plus m1 m2. Okay, so tan of 45 degrees is 1, modulus 1 by 2 minus m2, 1 plus m2 by 2. Okay, okay. Okay, so this inside part can be positive or negative, I don't know, right? Let us take it positive. There will be two cases, 1 by 2 minus m2 divided by 1 plus m2 by 2, and one more case where 1 is equal to minus. Okay, 1 by 2 minus m2 by 1 plus m2 by 2. There are two cases. Okay. Now I have to just solve this. 1 minus m2, 2, 1 minus 2m2, 2 plus m2, 1. You just simplify this. Okay, 2 plus m2, 1 minus 2m2, 2m2 goes there, dm2 minus 1, m2 is equal to minus 1 by 3. Okay, if I solve this equation, let me see what do I get. 1 minus 2m2, 2 plus m2. If I take this as minus 1 instead, I'll get minus 2 minus m2, 1 minus 2m2. Okay, I'll get minus 3 and minus m2. m2 is equal to 3. So there are two values for m2. Okay, m2 can be minus 1 by 3 or 3. Okay, this is how you solve. Because it is modulus, right? The inside part can be anything. It can be positive also, negative also. So we have taken both the cases, positive and negative case, and we found out. So there are two possibilities for that line. Okay, so this is how you solve. This was a very good question. So coming to equation, uh, as this video is becoming long, I'll be covering this in the next session. So let me just summarize what all things we did. So we'll be covering the equation in the next part. Okay, I'll be covering in the next video. Let us revise. Let me summarize what we did in this video. So slope of a line. First, we understood what is a slope. Slope is nothing but how steep it is, how steep a line is, that we can find out using tan theta. So this is nothing but tan theta. Theta is the angle made with the positive direction of x-axis taken in anti-clockwise direction. Okay, anti-clockwise direction. Okay. So when two lines are parallel, their slopes will be equal. When two lines are perpendicular, their product of their slopes will be minus 1, and angle between two lines, given their slopes m1 and m2, the angle between these two lines is found out using this formula, tan of theta. So this theta is acute angle. Okay, always. This formula gives us acute angle. Okay. Yes, so that's all. I hope this session was helpful to you. If it was helpful, please like this video, and you can subscribe to the channel so that you don't miss any of the videos. I'll be covering the entire topic in the coming videos. And please share this in your class WhatsApp group so that other students can also benefit from this. You can also join my Telegram group. The link is provided in the description. And one more thing, I would suggest you to refer the NCERT class 11 textbook. It is a very good textbook, so you can just refer that textbook, and that is enough for to crack the exam. Okay, thank you.